All right. It is a delight to welcome you all to this webinar on green hydrogen and how to assess the feasibility of real projects. My name is Anton Frisk, co-founder of Southern Lights, and we are hosting this webinar and also supporting with hydrogen project assessments and to help project developers to succeed in hydrogen development. So today we have a eminent panel of, let's see here, there we go, of panelists. So myself, I'm Anton Frisk, co-founder of Southern Lights. We have Felipe Gallardo, CTO and CEO and the co-founder of Southern Lights. He has over 10 years of experience in energy project development, been a technical consultant in hydrogen projects, for example, in Chile, and most recently a PhD candidate here in the Royal Institute of Technology in Stockholm, where we are. Hi, Felipe.
Hello, everyone. Thank you for the webinar, for the opportunity, for the organization. Super happy to be here and excited to be here.
Star guest, Carlos Benoy Lopez, senior consultant at Rabel. He is also an expert in the green hydrogen and power-to-X technology space with more than 17 years of experience in research and industry. He's also led R&D and business development projects for steel industry companies. And in his current role at Rumble, he helps companies to develop their power-to-X projects. He's also a very active thought leader on Twitter and LinkedIn. So we are very delighted to welcome Carlos Benoy Lopez.
Thank you very much, guys. It's a pleasure to be here.
Absolutely. So we have a packed agenda for this webinar on green hydrogen project assessment. First, some housekeeping, and then we'll move on to the path for hydrogen project development. We'll look at some case studies with Felipe. And after, Carlos will go deeper into the importance of energy prices and efficiency of these technologies. And we will have plenty of time for Q&A. So we really appreciate you writing all your questions in the chat box here. If you're on YouTube or in LinkedIn, you can write in the chat, and we will bring that up into the Q&A sessions. The recording is also on, so this webinar will be published later, so you can share it with your colleagues and friends. And we will also send out an email later so you can access some of the content that we have in this webinar. So take it from the start, basically, what is the path of green hydrogen development? Well, the motivation for developing green hydrogen projects is, of course, climate change. To meet net zero targets, we have to mitigate some of these greenhouse gas emissions from heavy industries, which account for up to 30%. And that's why we're investing, the global economy will invest 550 billion into green hydrogen project developments. The problem is that developing hydrogen projects is tough. The technology is not yet widespread and easy to understand for some, and feasibility studies cost a lot of money, and very few projects actually make it. So what we have in front of us is this project development funnel, as we call it, where you have to go through these stages of scoping a project, doing feasibility, doing engineering studies, detailed studies, and more. And our mission at Southern Lights is to get more projects to reach this ready-to-build stage with minimal waste of time, money, and efforts, basically. So here I want to invite in Carlos to just hear, like, what stages of projects are you working on, or where do you see the challenges today?
Yes, thank you, Anton. Well, right now we are working at the very beginning, trying to kind of see how a hydrogen project could have sense for many people. And I hope that with time we will go a little bit in all of the projects. We have also some projects at the at the building stage, but most of the projects are at the beginning, because it's where most of the industry is looking at this. Some people are sometimes even not understanding very well the green hydrogen picture. So I think it's also quite exciting to be on this route right now. The more challenging, I think, is that we all understand how this is possible to be done and where to make these pushers to help green hydrogen to become more and more a reality. I think this is the things that we will try to touch during the webinar and see where we go. So yeah.
Absolutely great. It's a delight to have you on with experience from the whole project development funnel. So just to dig deeper into like the first phases here and to understand a project, like you're saying, we're gonna just pinpoint some things that you are in need of to actually get to this ready to build stage. So Felipe, what is the first thing that comes to mind that a project developer needs to create a project?
I think that the first thing that comes to mind definitely it's a consideration to develop at an earlier stage the off-taker, right? So most of the developers working in green hydrogen development today comes from solar or wind or energy, electricity generation in general, and there. The off-taker of electricity is the electricity is a mature market. It's much more similar to a commodity than hydrogen. It's a gas, or its derivatives are not a commodity in that sense. So you need to understand the pressure, the temperature, things like the consumption profile, where it is located, because normally it's not just about finding a site, developing the project, and then finding the off-taker. The off-taker cannot be underestimated. Should be developed at an earlier stage, and I think that's a learning curve that all of us coming from energy development, from solar and wind, will have to integrate to develop hydrogen projects. Of course, yes.
Great point. Absolutely. Carlos, what else is on the menu here?
I agree with Felipe. I think we've been taking too much for granted that producing green hydrogen was enough, because we don't have any. But we need to take into consideration who or against which we are competing with. Sometimes we will be competing against gray hydrogen, sometimes we will be competing against natural gas or coal in the case of steel factories. So I think this is kind of the considerations that you need to take into account. What you are using your hydrogen for, because otherwise, I mean, you won't have a business case. If you let me add something more, maybe to say more that Felipe just said, maybe an extra thing is how we could be able to do this in a competitive manner. And this is where we are going to try to tell a little bit more details, where to start and how to actually break this barrier on having competitive green hydrogen that could replace all these things that we would like to do. Yeah.
Yes, exactly. Very good point. And some of the other puzzle pieces that go into making it competitive is, of course, like energy supply. Actually, you need permits to be able to build it. Technologies are also technology supplier is also a challenge, and of course, at the heart of all of this is, of course, the ability to do some assessment of these projects at an early stage to inform all these puzzle pieces needed. So great. So without further ado, we're going to jump into Felipes' part on showing like some case studies and how you can think about these things about hydrogen project assessments. So Felipe, the stage is yours.
All right. Thank you so much, Anton. I'm gonna share my screen now. You are sharing it already. Perfect. So let me go here. Southern Lights, as mentioned, I'm the CEO and founder of Southern Lights. So my presentation is also based on the work we do here. What does it mean to assess the feasibility of a project? So we are together here to discuss about how to assess the feasibility. What's the best way? How do we understand the feasibility of a real project? But what does it mean? What are we talking about? So some people, when we ask this, they relate it to the question: should we go off grid or on grid with the project? Should we supply the electricity with a dedicated asset for my electrolyzer so I can produce hydrogen with solar or wind directly connected to my electrolyzer, or should I procure that electricity through the grid? Should I use the PEM electrolyzer or an alkaline electrolyzer or a solid oxide electrolyzer? What is the electrolyzer I should use? So these questions appear when we discussed about assessing the feasibility. But ultimately, all these questions lead us to answer the final question, which is how can we make money? How can we maximize the internal rate of return and the net present value, for example, for the project investors that are investing in this amazing technology that will enable to decarbonize the economy? But ultimately, the projects that will work are the projects that will float, that will make sense from an economic point of view. And when we assess the feasibility, we are assessing the way to maximize technically and commercially and with strategic decisions how we are going to maximize the money we make out of a project. So where do we start? A project, for those of you working in project development, you are aware that the project is a very complex animal. In the center, you might have the project company, might be a joint venture, might be a small sized project company, it might be the internal department of a huge size company or an IPP, but you have always a project company that it's connecting the dots. So part of the dots you see on the left, you see the lenders, though the people that is going to lend you money. You have investors, private equity investors, project sponsors. You got to talk to the government normally, or to government institutions for permits, regulations, connection permits. You got to talk to contractors that will operate and maintain your project when it's built. You got to talk to an EPC company, so engineering, procurement, and construction. All of these players have their own consultants and have their own outsource for some of the activities they do. But where do we start when we want to do a project development, or we want to assess the feasibility of a green hydrogen project development? The answer is the off-taker. It's the most important variable. It's to understand the demand. Unlike some other energy projects where we can start identifying what's the best location to produce a project. So that's the case of solar and wind in some markets. And then we find the location, and then we figure out the optimal configuration of the projects, and then the connection point, and then we sell the electricity, and we know that along the way we're going to find someone that buys electricity in that market. Hydrogen is not like that. We need to know where the hydrogen or the ammonia or whatever we're going to do with this hydrogen, so the off-taker of hydrogen, where is it located and how does it consume hydrogen? We got to understand the demand. So demand prospection is, of course, the first step. We have current customers of hydrogen or hydrogen derivatives, might be people working in ammonia production, fertilizer production, refineries consume hydrogen, methanol, formic acid. So the industry that consumes today hydrogen, it's normally what we call the gray hydrogen. And there is a market there for green hydrogen to replace these current consumptions of gray hydrogen. So that's the first source. And the second one is the potential future hydrogen consumers or consumers of derivatives of hydrogen. So we have the steel industry. Sweden is betting hard on making their steel industry manufacturing green. We have the shipping industry, so marine transportation, heavy transportation in general. It's betting on hydrogen and its derivatives to decarbonize their economy. So it's problematic. It's difficult to electrify directly heavy transportation with batteries, and hydrogen might be there an option. So here are some of the potential off-takers. Very different, of course, the current customers, consumers, and potential consumers in the future that might consume hydrogen or derivatives. we got to characterize this because different use cases are going to have different demands. So in some cases, we need to produce with a flat production profile. We got to produce on site and continuously 24/7 to supply on demand the demand of hydrogen. Or we might be producing on a batch production scheme, charging, for example, the ships and exporting our hydrogen or derivatives to other markets. So important to understand demand profile, pressure, temperature, things like purity, local circumstances. Where are we sending the hydrogen to? Is there a port nearby? What's the infrastructure? Are they either prepared to receive the hydrogen? And what alternatives do they have? Are we just replacing gray hydrogen, or are we replacing another sort of fuel or chemical? What are the price requirements? What is the carbon footprint requirement? And so on. So that is about understanding the demand. But then, of course, we gotta build a project to support. So once we have understand the demand, it's about how do we best possible project in order for us to profit as much as possible, meeting the demand and the requirements of the case that we are assessing. So we got to scope and understand the feasibility and the engineering behind the potential solutions we could offer to this off-taker to supply the demand. And we have endless possibilities. So here I just show like two potential branches of possibilities. One, it's like we can produce hydrogen with a dedicated asset of solar and wind, and then produce that off-grid at a huge scale, and then we can produce ammonia and send that to the off-taker via trucks or ships, or we can just compress or liquefy it and do the same. Or we could produce hydrogen, depending what the off-taker says, we can send that also with pipelines or trucks. Or we can, instead of producing the hydrogen where the energy is low cost and then transporting the hydrogen, we could produce with a little bit more expensive electricity, but closer to the hydrogen consumption, right? So there is endless possibilities on how to configure a possible project. Each of them, it's very different on a technical level and on an economic level. So we need to understand the technical specifications and the economic alternatives of this. So I want to show just how difficult this is and how important it is to make the right assumptions and not to oversimplify this. So I'm going to show just a case, a very simple case of solar to hydrogen. So we want to produce hydrogen starting from solar. It's a 50 megawatt order of magnitude project. So I'm assuming we use PEM electrolyzers. And the off-taker can be flexible on the way we produce the hydrogen. So we can just produce during solar hours, and that's okay. The goal is to produce the hydrogen at the minimum possible levelized cost of hydrogen. So let's say we have two alternatives. One, it's on grid. The other one is off grid. So I can, produce the hydrogen connecting my electrolyzer to the grid and having a solar PPA for 50 megawatts. So that means that I'm going to have a very stable load factor that is guaranteed through the grid. I'm going to have a very low cost power purchase agreement for that energy because I'm consuming solar hours, but I'm connected to the grid. So I need to pay transmission fees. I need to pay for the use of the grid and ancillary services and whatnot. And I need to also finance the connection to the grid. Whether if I do it off grid, I will build my own plant. So I need to build, I'm going to build a slightly higher photovoltaic PV plant. So I need to think of things such as the DC-AC ratio, single axis tracking. The plant factor is not going to be as good as if I have a solar PPA through the grid, because I will have all the variations of an asset producing locally. I need to think of the location. And my LCOE is going to be comparable, perhaps a little bit more expensive than the PPA, but comparable in price. But then I don't have transmission fees. But I need to deal with all the problems of deploying a local asset, right? So if I don't have that experience, that might be a little bit complicated. So different type of projects, completely different type of projects to produce the same solar to hydrogen. And different projects lead to different operational results. So if I go with a PPA, which would be the blue line, I make sure that I get stable energy on the solar hours provided by whoever I'm buying the electricity from. If I have a real asset generating the hydrogen and I'm operating off grid, then I'm going to have variations on days. The production is going to depend on when the sun is up and like it's whether it's cloudy or not. So no matter how much you want these two curves to be similar, the off grid and the on grid, it's just different production profiles. And what I did this exercise on purpose a little bit, just to show you that even two completely different projects can lead you to the exact same levelized cost of hydrogen. So in this case, the on-grid, it's a little bit more expensive in terms of the cost of the energy, because we are assigning to the cost of the energy the transmission fees and the ancillary services. And then we have the capex is a little bit cheaper because the project is a little bit smaller, but then we end up with a total cost of hydrogen of $5.3 per kilo of hydrogen. And then if we do this off grid, the cost structure is different, of course, because the cost of energy is a little bit cheaper. I'm not paying for transmission fees, but the capex is a little bit larger because I need to have like a grid forming inverters and a little bit more oversized solar park and so on. But I end up with virtually the same cost. So what I want to show you here is there's no silver bullets. You cannot answer questions like from without knowing exactly the type of project you are serving, the type of demand you are serving. Sometimes on grid is better than off grid. Sometimes off grid is better than on grid. Sometimes CO2 footprint it's different. So it's not only about LCOH, production profile, capex, access to capital. So it might differ for 100 reasons. It's very important to remember there's no silver bullets or given formulas, and it's very easy to oversimplify this. So do not oversimplify this. Take the proper time to assess the proper configurations and consider the proper assumptions, and we can help you to do that with Southern Lights. We are a software to do this techno-economic analysis of all these options you might have once you have understand the demand you want to serve. So that's my presentation for today. That's the last thing I have to say. Thank you for that.
Great. Thank you, Felipe, for that case study. Very interesting to see the results of this solar to hydrogen. Next up, we have Carlos Benoit Lopez. So you are invited to the stage.
Thank you. Let me try to see if I can also share the screen and get the presentation up. It seems
There we see.
that is coming. Now I'm gonna put it in presentation mode.
Perfect. We see it.
Yep. So now I can try to guide you through the slides. So first of all, again, thank you very much, guys, for having me the chance to tell a little bit of the things that we are working at Rumble, trying to connect the technology with the importance of the electricity price and the efficiency. So let me just start giving you right on to the technologies, right? Felipe already tell us a little bit an example using PEM, but most of you know that these days we are working with three main technologies with different characteristics between themselves. It is important that we understand the different characteristics to see where we would use them later in a certain project. So we have alkaline, we have PEM, and we have SOEC. Alkaline is the much more established one, the much more mature, but at the same time, it has the higher footprint. You could see there for the size of the stacks, 15 cube meters versus the others. And at the same time, it has the smaller energy, the smaller efficiency, so the higher energy consumption together with PEM. When you see there 51 and 52 kilowatt hour per kilo. When we talk about efficient, when we talk about lifetimes, we could see that alkaline and PEM are also the best, led by alkaline, later by PEM. And then we have SOEC. The good things about SOEC is that it is a very high efficient technology with efficiencies that could be up to 95% if we connect it to a external heat. The reason to be so efficient is that it works at high temperature, it works at the thermoneutral point of the water reaction, and it takes advantage of this thermodynamics characteristic of the water, of the steam electrolysis in this case. So when you are facing the project and you are facing the feasibility of a project and you try to calculate your LCOH, your levelized cost of hydrogen, you see that the electrolysis technology has a big impact. But what you realize also when you start to do a few numbers is that Opex kind of have a much larger impact than capex. It doesn't mean that you don't have to pay attention to capex, but Opex will kind of give you the main effect to your LCOH. So in OPEX, we will be talking about the energy consumption, so kilowatt hour per kilo, but also the lifetime and the operation and maintenance of the equipment. Here you got an example for some of you who follow me in social media. You probably have seen already this graph, just how much we have of the reduction of LCOH when we reduce 50% capex or just 25% opex, and we see that the reduction is much more higher in the OPEX case when we are only talking about 25%. You can imagine that this is by playing with the high efficient technology with the lowest efficient technology. So that means that one needs to kind of keep an eye of the electricity price. Here I just represent LCOH versus electricity price, and two cases with high capex and low opex in the green slope, and low capex and high opex in the red slope. One can see that the higher we go in electricity price, the more difference we get. So when we get low electricity prices, capex and opex means much more. But we know that electricity prices as low as 20, 25 euros per megawatt hour are difficult these days to obtain yet. This also make us to kind of realize what we are competing against, right? As Felipe said, we are in many cases trying to replace gray hydrogen, and depending on where we are facing different prices of the gray hydrogen, different cost of production of this gray hydrogen. So if we are in the EU, we are these days having much more, let's say, room for us, because we would be competing against a much more mild competitor. But for instance, for our colleagues in the US, they have a tough competition when they need to kind of find a replacement for this gray hydrogen, because you know that natural gas is quite cheap over there. So that kind of make us think and realize about the different options regarding renewable. Here you see the table where we got the current prices of the electricity price on different countries in Europe. You see that Spain, Sweden are good countries regarding the solar and the wind asset, while the others are a bit struggling. They are a bit in the 50 scale. Maybe France is starting to get closer with the wind, and also the Netherlands and the UK. But we cannot either rely on the grid, because you see how the electricity average prices are very high. So that kind of make us to kind of connect these 2 points. We need to kind of realize that if we want to kind of make a competitive green hydrogen project, we need to know what is our electricity price. So we should actually try to go for the places where we got low electricity prices, and then could also, when we go in the high electricity price margin or range, plays a little bit with our Opex and capex, as you could see from the slows, because a little bit of room it could be done there. So just my take-home message and perspective is that, of course, the technology matters. Um, and you need to kind of take care of your opex and capex, and make it very project specific. It's not a magic solution for a hydrogen project, so you need to actually understand what you're having. And we are also based here in north of Europe, I think it is also important to realize why the Nordics are becoming the hottest spot for green hydrogen projects, why there are these so many still projects coming now to the north, because here in the north the electricity is quite low. So then we will be on the left side of the on the screen, and being able to kind of get very low LCOHs. So this is it. This is my short speech, and I am happy to kind of answer your questions to whatever you may have. So thank you, guys.
Thank you so much, Carlos. Great to hear about these considerations of the energy prices. And we actually have, so now we're going into the questions and answers. So for all of you who are listening in, you feel free to pop on your questions in the chat box if you're on YouTube, where you can leave comments. And we actually have a question that I think is for you, Carlos. So this is from Niltin, and it is, on what basis do you select the type of electrolyzer for a particular application?
I guess here again we need to kind of understand the characteristics of our project. So I guess that when you are facing higher electricity prices, because you are in an area where your electricity prices are not so favorable, you would like to go with the high efficient technologies, SOECs. But at the same time, you would be also struggling with the availability of these technologies these days. You may want to build a 1 gigawatt project with this technology, and you would be a bit stuck with that, because you know that bigger than 10, 20, 50 megawatts, maybe it's going to be difficult to get SOEC manufacturers. So then you would be forced to go with the lowest one. So then you would need to kind of play with other parameters to try to kind of be able to do it. So I guess it is depending of your very case specific, what you need to actually find your right technology, and see if your project makes sense or not. This is also something that we need to also face. Sometimes maybe the answer is that, well, right now in here with these circumstances, you cannot actually make a competitive hydrogen project yet, either with an awesome technology. It's not possible.
And
Interesting.
I would like to complement that as well. So I think that it's I agree with everything that Carlos said, of course, but then I when I because I get this question a lot, right? Of course, when we talk to our clients and they say like, should I go with this or with the other one? So I think the first dimension of it, it's purely technical. So like depend on like what is the type of project you're doing. So if you're doing a project that is connected to an energy source that varies a lot, you're gonna make sure that you have an equipment, an electrolyzer that it's able to deal with these variations, and they're like, you might look more favorably to one technology instead of the other. If you have a very stable energy supply all the time, then you might, be more relaxed on that, and perhaps work with, I don't know, other technologies. Alkaline, it's always said to be not as flexible as PEM, for example, but then alkaline has made huge progress now. So its technology is advancing so much now, and it's really exciting, because it's of course about efficiency, but it's also about reliability, degradation, what are the wet hours that you're planning for in your electrolyzer. So there's the technical dimension is just huge, but then you have the commercial dimension. So most projects that we see today as well are like gigawatt scale, and then even if you select one technology, you're not going to have the same provider, so you're going to have to probably divide your provide. You have like a provider's portfolio or OEM portfolio, and then you might even change technology. So I think it's so many dimensions to this question. So the technical, the logistic, where are you in the world? Are you like extremely far from the provider? What happens if you have a problem when you're operating? So these kind of things you also need to consider. If you have a project that will have degradation because you intend to operate for 20 years and you need to have replacements, what happen if you gotta have a replacement? Is it a very small company? It's like a startup company that sold you the electrolyzer. So you need to consider as well this in a long-term perspective. So pretty exciting, and as said before, no silver bullets. Just compare everything and make a decision.
Great. So that's a very interesting topic. I think we'll come back to more questions. We have more questions here on the electrolysis, but we also have some questions on locations. So Seti is asking, hi Carlos, how do you assess Middle East for hydrogen as electricity prices are very low there?
Yes, I think this is actually a topic that when we were preparing the the webinar, we were talking a little bit about it. Yes, Middle East is a good spot. I think, as the best of my knowledge, you got very good sun and wind assets there that could increase the capacity factor of your electrolyzers, because this is other thing that we haven't talked yet, but the capacity factor of the electrolyzers will play an important role on your economic asset, on your economic figures that you're going to do, because you would like to run the electrolyzer the maximum hours as possible. And when you are in renewables, you would just operate them 30, 40, 50% maximum. So there are locations that the combination of sun and wind are much better, and I believe Middle East is good. But here, a but. You need to always think to make something good with your hydrogen. If you are thinking to export hydrogen from there as the molecule, you will have difficulties in the coming years to make this business model to work, from my point of view, as the transportation is something that is not so expensive that we used to think. But when we talk about small distances, we could be talking maximum 1,000 kilometers, but not few thousand kilometers. So this is something that you need to consider when you are taking about what are you making the hydrogen for? What Felipe was saying, the off-taker. Think always, what are you going to use the hydrogen for? Yeah.
Yes, and I would like to complement this. So imagine like what you actually want to do is to produce ammonia, and you're in the Middle East. So also in the same question as SETI, I think when you want to, like, when we talk about electrolytic green hydrogen, so green hydrogen via electrolysis, it's green because we are using green energy, clean energy. So if we're using clean energy, normally it means that this is a very intensive in capex project. So it's pure capex. I mean, you can take the cost of the energy as the levelized cost of energy and assume it's like an Opex or a variable cost, but in reality, it's a known price that it's the product of a capex and a project finance coming out of a solar park or a wind park or whatever. So it's very intensive in capex. And then you have the Haber-Bosch cycle if you want to produce ammonia, and it's pure capex as well. So and then it's electrified, and you electrify it also with renewable energy. So it's capex, capex, and capex. With project finance, you make it over the years, but it's very stable prices. So the resource, it's very important, of course, the solar resource, the energy resource, but as important is also the cost of money, because this is mainly infrastructure investment. This is capex investment. So, and I think that in Middle East, this might be a great advantage, because you have a very good combination of very strong energy resource, a very good access to money. So I think, and ammonia, it's of course easier to transport and to handle. We know how to do that closer to environmental conditions, or what we call standard conditions. So environment, like atmospheric pressure, closer to atmospheric temperature as well. So if you want to produce ammonia, I think Middle East, it's rather one of the best places today, depending on where do you want to get. Of course, you need to study how much it costs you, and how much are they going to pay you, where it's going to be consumed. If it's for fertilizers, perhaps you need to compete also with gray, or with natural gas. If it's for explosives, for mining industry. But yeah,
Which market are
it's
you
many
competing
many
against?
factors.
Yeah. Mm.
Yeah, of course, and it's also the geopolitical factors, as you know, today playing in Europe especially. So very, very interesting question. What's the role of the Middle East? I think we'll have to wait and see.
So this brings us to a question we got through another channel, because now we're talking about exporting hydrogen as well. And this was question came up like, what are the alternatives of exporting overseas as hydrogen or as derivatives, and which are the best options? And then they list some things there: ammonia, methanol, liquid organic carriers, etc. What's your take on this?
I mean, what I would say is that all the options are possible, and what I guess in the next years, maybe very long distances are going to be difficult to realize. But I think this is possible to make. But you need to have the business case behind you, where to get your methanol, for instance, to be consumed. Let's say that you do it in the Middle East, right? And you decide to do a methanol plant there. Where are you going to sell your methanol? Against whom you are competing, right? That's what would be my main doubt, rather than the technical possibility, or the possibility of other options to transport the hydrogen. I don't know what you think, Felipe, about these things.
Yes, I'm gonna disagree a little bit. This is fun. So it's a slightly different opinion. So I think, when we look at the history of hydrogen, it's obviously hydrogen is super difficult to move around. It's like, the lightest the molecule, it's difficult to move around, and this is why 97-98% of all the projects that produce hydrogen, gray hydrogen, but hydrogen, are on site. So it's
Yep.
produced where it's consumed, because it's much easier to move natural gas today. So now the revolutionary idea behind green hydrogen is that renewable energy has become so cheap that we can use it to break water and produce green hydrogen. But that is true only where we have a lot of renewable electricity, and it's very, very cheap. And it's normally very far away from the consumption poles, right? So it's in the Atacama Desert in Chile, or in, I don't know, in places far away. So we need to transport it. And I think with technology, from a technological point of view, the technology to transport hydrogen as a molecule, it's not mature. So it's a lot of technology being developed, but it's not mature. And it's much easier to transport using carriers that are stable and easy to transport at environmental conditions. So I think that these carriers, and in particular ammonia and methanol, I don't know, liquid also organic, but I think these are going to be the main vectors to transport hydrogen, at least in the midterm. And then in the future we'll see. But this challenge of go and get the green hydrogen wherever it's cheap and then transport it, it's also a challenge from a technical point of view, because we don't know how to transport hydrogen yet. We were figuring this out, but it also imposes costs, right? So whatever I'm making the hydrogen cheap for, because I'm looking the cheap electricity, I might lose if the transportation is too long. So it's a
Yeah,
very interesting challenge. I would advise to use Southern Lights to solve it.
yeah.
All right. So we have another location question here by Uma, which is similar. So this is like, how do you see India with respect to hydrogen project feasibility? Do you see anything different compared to the Middle East and Europe in this case?
I must admit that my knowledge about India is not very big. I guess you will need to analyze again your access to renewable electricity. In the places where you will have abundant and cheap renewable electricity, you would have a quicker business case for a green hydrogen project. And again, what purpose you are giving to that green hydrogen project? So, are you competing against very cheap fertilizers with very low natural gas? Well, maybe that's not your best option. Maybe you should go somewhere else. But yes, I guess that it is a huge country with plenty of possibilities. Maybe Felipe, you are a little bit more knowledgeable about India than myself. What would you say?
I must recognize I'm not knowledgeable about the Indian market, so I guess my answer would be also to look at the variables that we have talked or discussed in the presentations and how to approach this. And yeah, we could take it also in private with the person asking this to see how we could help. But
Sounds
yeah,
like we need a Indian hydrogen expert on the upcoming webinar, possibly.
Yeah, that would be good to learn.
So here's a bit of a longer question about the PEM technology, which has, of course, a lot of different advantages. Say high efficiency, fast startup, compact size, safety, durability. Will PEM overtake alkaline electrolysis in the future? Is Lakshmi's question.
I don't
Carlos, what do you
think
think?
we will be having any overtaking of any technology in the future. I think we need so many technologies, so many gigawatts to be built that all the technologies will have room for existence. Maybe in 15 years time something will be different, but 15 years is a lot of time, and imagine where were you 15 years ago. So we'll see when we will be 15 years in the future. Yes, PEM has advantages versus others. So maybe when you will be having an offshore project with very limited space and with a lot of variability, you would be rather taking a PEM technology. When you maybe want to have a hydrogen filling station in a very compact area because you want to put somewhere in a very limited space that you got, you would choose also PEM. But with other characteristics, you would choose alkaline or even SOEC. So I don't see that any of the technologies will have a much like 80% of the share. Maybe we reach 50 to some of them, but I don't know. We'll see.
Yeah, and there's a similar question here by Mangesh. What do you think about the anionic exchange membrane technology, which is a hot topic coming up?
It is a very promising technology. It is like with also other developments that we have seen in the other three technologies. It has a lot of potential, but it has still a lot of room to do. I think it will have some importance because it's cheap, because it is a membrane technology that is always have many attractions to the connection with the variability, but it has like 5-6 years probably of disadvantage catching up. So, but there is so much electrolyzers to be built that maybe a big share it will be enough for, I don't know, a bunch of manufacturers making them. So yeah, I don't see it as a big obstacle to succeed, but either like it will you know destroy the others.
Right. So the opportunity window is still open for these new technologies. That's
Yes, that
exciting
would
to
be.
see how things pan out then. We have one which I want to direct to you, Felipe, from WADA, is asking, how do you see frequency regulation and other grid services providing a complementary revenue stream for the grid-connected electrolyzers in the future?
Well, I think this is a very exciting question. Revenue stacking, it's important for all sorts of energy infrastructure projects today. So not only for electrolyzers, but for batteries. We've seen that with, so as markets become more competitive, these sort of projects need to have different revenue streams to complement their profitability. And I think it would be unwise to not use, I'm thinking of a systemic level, not to use all the beautiful potential of these beautiful technologies that are electrolyzers. When we want to produce hydrogen, depending on the way and depending on the project we are supplying the hydrogen for, we might have, for example, a hydrogen goal per month. If we have a hydrogen goal to reach each month, or because a ship is going to come, or like depending on the way we're storing it to supply it to the consumer, we might have a goal per month, and then we can play around with the immediate or instantaneous operational point of the electrolyzer. So for example, to provide frequency regulation, not through a fuel cell, but through the electrolyzer itself. So we can regulate how much load we give to the grid. So normally, to regulate the frequency in the electrical system, we control the generation. But here we have an electricity consumption device, a load that is very much manageable. And sometimes if we know that we're going to reach a goal of hydrogen by the end of the month, we don't care if like in 1 minute we go with our consumption low, or like we ask the electrolyzer to go that full power in order to compensate for whatever is going on the generation side. Therefore, providing frequency regulation or voltage control or some other things. So the technology, depending on the technology, of course, is very much available, and it's possible today to give ancillary services to the grids. Now, on the technology part, it's ready to go, I would say, in many cases. I'm sure the people behind the business is also very much eager to give these services. The problem is regulation. So ancillary services, things like frequency regulation, have proven to be very, very, very slow. In general, for us to get the regulation. So in markets such as Europe, but also, for example, I'm from Chile. In Chile as well, we have been discussing about ancillary services for a year, and like it's not common that these devices provide these ancillary services. So I think it would be great that more markets have allow electrolyzers to provide ancillary services. I'm not super optimistic in most of the markets because of all the regulatory conversations that needs to be in place for these devices, or for demand to be manageable to provide ancillary services in most markets. But it's possible. I would say it would be ideal that they could do it, and let's see how we are going to be able to do that. Revenue stacking, it's important for this.
And I like to add that again, this will vary a lot from places to places. And when we talk about the future, some of them, it could have a very short space, because actually that will depend a lot on how much extension of renewables we will have. The more renewables we will have available, the less sense it will have to have a certain ancillary service. So I guess we will be increasing our renewables, and depending how fast this will be done, maybe in some countries like here in the Nordics, it's very fast. We are very close, so maybe ancillary services are for the coming years. So when you talk about future, what you mean? I mean, you mean 2035? Well, maybe not there, but maybe in another country, yes, because the renewables would be slower, because we know that we will be having development of the renewables in different speeds in the world. So that could be also very important to keep in mind, that it won't be the case in Chile, than in India, than in Indonesia, than here in Europe. For all the things also that Felipe has said about regulations and so on. So, yeah.
I have to come in with a question of my own here. So, like, if we then start acting on this frequency regulation and going up and down with electrolyzers a lot, how does that change the degradation of these stacks?
This is a very good question, Anton. And to be honest, I think we are still to see how the impact is going. I think we need to be honest here also on the way that we assess the technologies. We cannot give answers to anything and realize that there are things that they are completely new, that they haven't been tested in a very extensive manner, and we are going to learn as we do. So there are technologies that will be affected less than others. There will be technologies that will be much more suitable to do this, but it doesn't mean that some ancillary services couldn't be done with other technologies. And I guess we will learn as we will see this as we do with all renewables on the years. But this is a very interesting question to watch, Anton. Yeah.
I would like to compliment as well. I think it's one very good example in the of what Carlos is saying is that for the case of lithium-ion batteries, it's very difficult to predict how they will degrade. And imagine the amount of data that we have on lithium-ion batteries. It's like we have gigawatts and if not terawatts of like lithium-ion batteries working around the world. And with all the data, it's extremely difficult still to predict how they degrade. Now, topologically, they are not so different, right? Electrochemical devices with electrodes. So for hydrogen and for electrolyzers, that with the little hours of operation that we have, for the capacity that is installed, it's very difficult to predict what is going to be the degradation, even when you don't give ancillary services. Now, if then you give ancillary services, and then you have degradation in different components, right? For sure, you have the degradation of the electronics part, the balance of plant of the stack, the balance of plant of the plant, and so on. So amazing question to be solved with more data. Now we have, of course, the predictions, and there is way developers can protect themselves against this risk. They have to pay for it normally to be protected, and they have to negotiate in terms of warranties where with their OEMs, with their tech providers. It's a huge question.
Yeah, let me add also one thing here also as a scientist, as a background, I need to say that the importance to get data these days is crucial. You know, that's why we need to put projects to work, projects to happen. And when more data it will be available, we will be improving much more. And that's the way that all the renewable technologies has been able to have this faster learning curve by deployment of the technologies. And this is what we need right now. We need to actually focus that this is actually we need to push to happen. So and I'm sure that we will be able to do it. So yeah.
Great. We are reaching the end here, and my takeaway from this session is that there's a lot of things to consider in a hydrogen project, and we got some great questions here that allowed us to deviate into some of those and go deeper on some of those topics. So thank you guys so much, and thanks to the audience for all the different questions. We, of course, want to continue this conversation with you. So, Carlos, where do we follow your work?
Yes, I think the best is to follow my LinkedIn account. I post regularly there, and you could easily find me with my name. I also have a newsletter, the High Date newsletter, trying to be with at least once a month. I'm doing this in my spare time, so sometimes I'm not so frequent in my publication as I like. But please reach out through LinkedIn. I normally answer during the day. So don't be shy. We could talk about anything, and we could be helping each other in many ways. Yeah. And thank you guys to have me here. It's been a great pleasure. Yeah.
Great. I made sure to post your links here in the chat boxes as well. And
Thanks.
for us at Southern Lights, of course, if you're interested in seeing more about our product that helps you do hydrogen assessments, of course, we are always available to continue this conversation. So you can find us on southernlights.io or email Felipe directly if you have questions on the parts that he showed. And yeah, you can also scan this QR code and get directly to our booking page to have a chat with us. So, Felipe, do you have any last remarks you want to say before we leave?
Thank you so much. This was fun. Thank you so much, Carlos, also for having the time and debating about hydrogen and its future and how to assess real projects. I think for me, bottom line is that it's a difficult job, and it cannot be oversimplified. But you have a lot of problems when you oversimplify it, and you might be off by several dollars per kilo of hydrogen, and that might create frustration with your clients afterwards. So take this seriously, and we look forward to help people and doing this. So yeah, this was fun, and thank you everybody for coming.
Thank you so much, and reach out to us if you have ideas or suggestions of what to talk about in coming webinars as well. That concludes today. Thank you.